Good morning, ladies. Good Thursday to you. Wednesday night here at our house while I'm making this video, but Thursday morning there for you. Hope you guys are doing well. And I do not have the calendar in front of me. I'm going strictly from memory, but I think the senior sale or senior whatever you guys call it thing was this week. If I'm wrong, then ignore this, but if I'm right, I hope that it's gone well. Hope you guys have made some money. And let's get to work. Let's see. There'll be a test on Tuesday, so tomorrow you'll have a review sheet, and Monday. Giving you guys plenty of time to work on that. Let's see. You do not owe me homework. You do not owe me homework. There was no homework last night. Unless you're late on Monday or Tuesdays, then get that turned in by Friday. Any homework not turned in this week will be a 0 unless you contact me with a detailed explanation. Let's see, Ashley test by Friday. Please don't forget that. Ashley test by Friday. And that's basically it. We're not going to start off with any activities or warm up today. We're going to get right into the notes for a couple reasons. First of all, we just had a quiz, so we have reviewed the entire chapter on that quiz. And secondly, and I hope you all did well on your quiz, guys. I hope you're figuring out a couple things. A, you got to study for this class, and B, if you struggle in math, your bread and butter to pass this class is learning the fill in the blanks. Okay, it might take some of you longer than others to memorize, but everyone can memorize. Okay, and so that's really going to be the key that helps you compensate for some of the math problems you missed. But anyways, we're jumping right into the notes because A, we just had a review, and B, I want to always try to give you some homework time so you're not taking so much home with you. With that in mind, please grab your notebooks. I'll give you just about 10 seconds to do that. So please grab your notebooks, your pencils, and your brains and be ready to work. Okay, by the way, throughout the entire class period, we're going to be using pi a lot. Keep that in mind. And we're going to use 3.14 for pi. Okay, so keep that in mind. Okay, here's your heading. Write that down, please. We are going to look at something that's almost as easy, not quite, as finding areas of rectangles. And so we're looking at how to find the circumference and area of circles. And the lesson number is 8.7, and the date today is the 14th. The 14th. Okay, so take a second, copy this down, and let's get started. All right. There's about 3 or 4 definitions I need to give you, unfortunately. And so we're going to start off with 4 definitions and then get into some problems, okay? You do need to know the geometric definition of a circle, so please copy that down. A circle is the set of all points in a plane that are the same distance. Sorry, I feel a yawn coming on. They're the same distance from a given point called the center. Now, whatever I draw here in a second, it's going to disappear right away, so it's not going to stay here long. And you do not need to draw this diagram. You do not need to. I'm just trying to show you something, okay? Here's the center of the circle right here. Do you see that? And notice how all of these points on this circle, all of the points on this circle are the same distance from the center, and that's what the definition means. Okay, it means you can put a point anywhere on this edge of the circle and draw a line to the center, and all of these distances are going to be the same. So what is a circle? It's the set of all points in a plane that are the same distance from a given point called the center. Now, one more thing you do need to know. There is a way to denote circles, and I don't think you need to write this down, but this is called circle A. You always call a circle by its center, and you know how we have stuff like triangle, ABC? Well, we have a symbol for circles, and it's just like this, a little circle with a dot in the middle, and then you would put A, and that means circle A. So that's a little symbolism right there that we're going to use. That means symbol, that means circle A, or whatever the circle might be. A circle is always named by its center. Okay, hopefully you've copied this definition down. Let's continue on. You need to know what a radius is. Radius is the distance from the center to a point on a circle. And again, you do not need to write this diagram down unless you want to. Just kind of watch as you're copying this definition right here. Radius is the distance from the center to a point on the circle. So here's the center, and there is the distance from the center to the edge of the circle. We'll call this segment AB, and that segment is called the radius. Do y'all see that okay? Pretty much elementary, you should know this. The radius is the distance from the center to a point on the circle. If I'm going too fast, just rewind the video. Okay, you need to know what the diameter is. Diameter is the distance across the circle through the center, okay? It's very important, through the center. So the diameter is a segment, and go ahead and just copy down the definition. Just kind of listen to me while you're copying it down. There's the center. A segment that goes like this would not be the diameter because it did not go through the center of the circle. The diameter must go through the center of the circle, and it must go through the entire circle, passing through the center. So a diameter is the distance across the circle through the center. So it's really 2 radii, okay? Radii is plural for radius. Here's a radius, here's a radius. They're put together, and this whole line is called a diameter, okay? Again, this is pretty elementary, okay? So we've so far had a definition for circle, radius, diameter. And now let's take a look at what circumference means. Circumference is the distance around a circle, okay? Distance around the circle. All right, for example, students, if this were a bird's eye view of a swimming pool and you were up in the air looking down on a circular shaped swimming pool and you wanted to put a privacy fence around your swimming pool, you would want to find the circumference of the pool. You would want to find the distance around the outside of the pool. Now granted, you might not put the fence right on the edge of your pool, but nonetheless you would want to find a circular distance around your pool. And that's what circumference is. It's the distance around a circle. Okay? So please understand that. The distance around a circle. All right? I'll pause for about 10 seconds, grab a little drink of water here. You guys can finish copying these definitions down, then we're going to move on. Okay, let's start off. Please copy this in your notes. Now, let me start off by saying you don't have to draw the circle if you don't want to. For your problems right now in your notes, if you just want to write radius of 4, that's good enough. If you want to draw the picture, that's fine too. That's up to you. So all the problems we're going to do today, you don't have to draw the circle if you don't want to. We're going to find the circumference. In other words, we're going to find the distance around this circle. Here's the formula I would like us to use. Really simple. Pi d. That's it. Isn't that easy? Pi d. That's it. So let's go ahead and find the circumference around, or the circumference of the circle. Well, circumference equals, for pi, I'm going to put 3.14. And now for d, d stands for my diameter. Now think about it, students. If the radius is 4, and the diameter, of course, goes all the way through, that's just like 2 radii. So if the radius is 4, then obviously the diameter is going to be 8. You have 2 4s, a 4 and a 4, okay? And so, I'm trying to look, I had all the answers written out. Well, I'll go ahead and just pause the video here in a second, but if you take 8 times 3.14, your circumference is going to be 32, carry your 3, 1, carry your 1, 25.12, okay? So there's the circumference around the circle. Let's just go ahead and say this was inches. So the distance around the circle is 25.12 inches around the circle. Okay, students, let's try another one here and see how you guys do. You can work ahead or watch me. This is not for bonus points. But what if I asked you to find the circumference of this circle? Now, again, you're welcome to draw the diagram, or you can just write diameter equals 16. That's up to you, okay, whatever works for you. But let's find the circumference of this circle. Okay, you can work ahead or wait for me. I'm just kind of pausing for y'all to get caught up. Find the circumference of this circle. In other words, find the distance around this circle. Okay? Alright, here's the formula you should use whenever I ask you to find the circumference of a circle. Please use pi d. Okay, so where pi is, I'm going to substitute 3.14. And where d is, I'm going to substitute 16 because on this problem I gave you the diameter at 16. And if you take 3.14 times 16, you will get 50.24. Let's go ahead and call this diameter feet. So 50.24 feet. Notice I'm not saying square feet. This is not area, students. This is circumference. Let's go back a problem. Notice I did not put square inches, just inches. We're not finding area, so we do not use the word square. Okay, do not pause the video, please. I'm going to let it run. I want you to go ahead and find, for a bonus point, the circumference of this circle. Now, I am going to start working on it right here, right away. Okay, so as soon as you're done copying this down, don't look up again, and just let the video run, and I will go over it in just a minute. So quickly copy this down. I'm going to start solving it right here. Don't look up until you're finished. Find the circumference of the circle that has a radius of 9. Okay, a couple more seconds. If you're not done, feel free to pause the video in just a second. All right, I'm going to go ahead and slowly start going over this. Here's the formula you should have used. C equals pi d. Notice for pi, I make this substitution. Notice for d, I make this substitution. Your radius was 9. I hope you didn't use 9, students. You should have used 18. And then if you multiply those together, you will get the answer. That's for one bonus point. Okay? So far we've studied how to find the circumference or the distance around a circle. All right? Now let's go back to that pool example for a second, okay? Let's say that I was trying to, here's my swimming pool, and let's say I wanted to purchase a circular solar cover that goes across the pool and keeps the heat in the water. Well, if I was to do that, then what I would be looking for, of course, is something that covers the pool like this. It doesn't go around the pool, it goes on top of the pool. And I'm taking my highlighter here and I'm kind of coloring this in for you. Alright, so what if you wanted to purchase a cover for your pool? You wouldn't want to find the circumference, the distance around it. You would want to find the area of the circle. How much space does your circle take up? So now let's get into finding the area of a circle. Alright, so as I'm kind of rambling here, I want you to go ahead and copy down this problem. Again, if you don't want to draw the circle, you can just put radius equals 7. That's fine. And we're going to find the area. That means the space inside the circle. We're going to find the area of the circle. And here's the formula you need to use. A equals pi r squared. Okay? So you take your radius, you square it, and then after you square it, you multiply it by 3.14. Alright, so let's go ahead and work this out together. If you want to work ahead, that's fine. Let's go ahead and find the area of this circle. For pi, I'm going to use 3.14. For my radius, I'm going to use 7 because, well, my radius is 7. Now, some students would first multiply these two numbers together, and then whatever they get out, square it. And that's wrong, and you will miss the problem every time that you do that. You want to first square the radius, In this case, you would get 49 because 7 times 7 is 49. And then after you've squared the radius, you multiply it by 3.14. In this case, you will get 153.94. Now this is area. I'm going to go ahead and call this yards. So our answer would be yards squared, or square yards. So there you go. If I ask you to find the circumference of a circle, you use this formula right here. Okay? If I ask you to find the area of a circle, you use this formula right here. Let's do one more and then I'll give you a chance to earn some bonus points, okay? All right, you can work ahead or watch me. I'm telling you the entire diameter is 26. You're welcome to copy this problem down, or you can just write in your notes diameter equals 26. That's up to you. All right, I'm going to go ahead and get started. We're going to find the area of this circle. So A equals pi r squared. All right, so for my pi, I'm going to substitute 3.14. And for my radius, look what I put. Now students, be careful. If my whole diameter is 26, cut that in half. That means my space from here to here is 13. Kind of highlighting that in red for you there. All right, and then of course my space from here to here is also 13. So my radius is 13. So you want to put a 13 in for your radius and then square it. All right. Well, I'm not sure what you get when you square 13 times 13. I think it's 169. I do know what the final answer is. I'm about 99% sure 13 times 13 is 169. And then you take that times 3.14 and your final answer will be 530.66. Now I didn't give you a measurement on this, inches or yards or whatever, so I'm just going to say square units. All right, so there, you found another circle. Okay, let that sink in for a second. I'm a bonus. Okay, here you go. Try this for a bonus point. You can copy down the circle if you'd like to for your notes. That's totally fine. Or you can just write off to the side, find the circle that has a radius of 6. Either way is fine. I'll give you a couple seconds to copy this down, then I'm going to work it out right here. So please don't look up here again once you've copied this down. Let the video run, please. Give you a couple more seconds to copy this down, and then go ahead and try to find the area of this circle for one bonus point. All right, I'm going to start working on it here, so please do not look up until you're finished. Be sure and label your answer correctly. We're going to call this meters, 6 meters. So don't forget how to label your answer. And do not look up until you're finished, please. Give you a couple more seconds to finish your answer. Okay, if you need to pause the video, feel free to do that. I'm going to go over the answer. So here we go. If you're not finished, you can pause the video, or if you're almost done, just go ahead and keep working on it. Here's the formula you should have used. A equals pi r squared. You should have made these substitutions right here. You should have put this in for pi. You should have put this in for your radius. Next, you do not multiply those two numbers together. That would be incorrect. Instead, you square this and you get this. And now you can multiply these two numbers together and you should get this answer right here. Okay, so give yourself the bonus point if you got it right. We have left, I think, a couple more problems. I believe. Sorry, there we go. We have about 2 or 3 problems left and a couple of definitions, and we're almost done, so hang in there, okay? Now, let's move on. Let's see how smart you guys are. Look at that. I wrote that right here. Let's see how smart you ladies are. How about if I give you the area and you find the diameter and the radius, okay? I hear those cheers. I know you guys are excited to do this, so here we go. Let's go ahead and write our formula. Now, am I going to use my circumference formula or am I going to use my area formula? Well, what you have to do is you have to look at what I gave you. If I gave you the circumference, then you would use the circumference formula. But did I give you the circumference? No, I did not. I used the area. Excuse me, I gave you the area. And so because I gave you the area, we're going to have to use the area formula. All right? A equals pi r squared. I'm sitting here teaching you guys in the living room. My wife just fell over on the couch and started sleeping. I hope I'm not putting you guys to sleep while I'm teaching. Wow, she's like passed out. I am a wonderful teacher. Well, anyways, let's move on here. So we're going to see if we can find the radius. Then after we find the radius, we will then try to find the diameter. So for A, I'm going to substitute 380. Everybody have that okay? For pi, I'm going to substitute 3.14. And then for r, well, it's going to stay r squared. Now, this is not going to be easy, but again, I'm trying to challenge you. Let's see how smart you ladies are. And I think you guys are very smart. I think you can get this, okay? We're solving for r, right? So let's go ahead and divide both sides by 3.14. That makes sense to me. Divide by 3.14. Divide by 3.14. Now let me glance at my notes and see if I have this done. And I'm surprised. I figured I would, but I don't. So I apologize. That's my fault. So if you take 380 and divide it by 3.14, you will get this right here. Okay, you should get approximately, now I'm kind of rounding, approximately 122, I believe. I kind of did it quickly off to the side. And now look, remember how we learned this in Algebra 2? If you have r squared, or in bridge math, you take the square root of r squared, but if you take the square root of one side, you've got to take the square root of the other side. Now you guys are really used to putting plus minus, but I want to warn you against that. You're trying to find the radius, and how in the world could a radius be negative? Do you see what I mean? Do you see what I mean? A radius cannot be negative, so in this case we're not going to put plus minus, okay? But moving on, we now take the square root of r squared. We're left with r. And we take the square root of 122, and we get approximately 11. So there, you found the radius. We're just going to round it to 11. Now hold it. If that's the radius, then the diameter is always twice as big, so the diameter is going to be 22. Look at that. Pretty tough problem. I'm going to throw a couple of these at you in your homework, so make sure you practice these and make sure you watch the help video if you struggle on these, okay? All right, 2 more definitions, 2 more problems, and we're done. So please, please hang in there, okay? Please hang in there, and here we go. Copy this definition down. You do need to know what a central angle is. A central angle is an angle whose vertex is at the center of a circle. So I would encourage you to go ahead and draw a picture of this after you've copied the definition down. An angle, a central angle, is an angle whose vertex is at the center. I would encourage you to draw a picture of this so you can see this. This would be called a central angle right here because the vertex of the angle is right at the center, and of course the angle has to go all the way out and hit or intersect the sides of the circle. So there's my central angle right here. Okay, so a central angle is an angle whose vertex is at the center. Now, a region of a circle is determined by 2 radii. Okay, so copy this down. Or excuse me, I apologize, a sector. A sector of a circle is a region of a circle determined by 2 radii. Okay, so a sector is a region of a circle determined by 2 radii. And let me give you a picture of that so you're not confused. If I had a central angle that went like this and this, then what we call the sector is the part on the inside of that angle. It's all of this area in here. That's pretty easy. And that's called your sector, okay? So a sector of a circle is the region, and here's your region right here, of the circle determined or made by two radii. And this is a radii, is it not? And this is a radii, is it not? Sure it is. Or a radius and a radius. So this is your region right here. This whole area here is called your sector, okay? That is a region determined by two radii. So with that in mind, we're now going to attack two problems. And can I warn you, these are really, really difficult. So please, please pay attention. Please take some good notes, okay? All right. I want you to find the area of just the shaded sector. So take a second if you would, please. Copy this problem into your notes. I want you to draw the circle, draw this central angle here of 120 degrees, and then color that area in with your pencil, however you want to do it. And we're going to find this area right here of the sector. All right. So I'll pause while you copy this down. We'll do one more of these right here. Then we'll do your homework or get started on your homework, and we'll be finished for the day. Now what I'm going to do while you're copying this down, I'm going to explain this to you. What I'm going to do is I'm going to first show you how to do it and not give you steps, and then I'll give you the steps when I'm done, because I really want you to try to see this on your own without steps. Steps are good, but you know, sometimes you need to do things without steps. So we'll kind of see what happens here, okay? All right, here we go. All right. The first thing you want to do is you want to find the area of the entire circle. Now what you're going to do is find the area of the entire circle, and then you're going to find what fraction this shaded area is, and then find that fraction of the whole area, and you're finished. Let me show you what I mean, okay? Let's first of all find the area of this entire circle. I'm going to do it really fast because we already know how to do it. A equals pi r squared. Now, Mr. Earhart, hold up. You told us to find the area of just the sector. I know that, but the first thing you have to do is find the area of the whole circle. So, the area of the whole circle is 3.14 times 9 squared. And if you square the 9, you get 81. If you take 81 times 3.14, you'll get 254.47. So just copy that down. Trust me, that's the area of the whole circle. Now, I have a question for you. If I drew a circle and cut it in half, and I said, what fraction of the circle is the shaded area? Hopefully you would say what? Well, that's half, Mr. Earhart. It's half the circle. And you would be right. That's exactly right. So it's not that hard to find fractions of circles. I mean, how many degrees are in a whole circle? Do y'all remember? Aren't there 360 degrees in a whole circle? Sure there are. And how many degrees do we have in this sector? 120, correct? So I'm simply going to put 120 over 360. And that fraction right there represents the fraction of this whole sector. Okay? Let me say that again. The whole circle is 360 degrees. I just want 120 degrees. So what fraction would that be of the entire circle? Well, it would be 120 over 360. Now let's reduce it. First of all, you can divide by 10. That would knock zeros off. Then 12 goes into both of these numbers. 12 goes into 12 once. 12 goes into 36 three times. So it looks like to me this entire fraction right here, or excuse me, this entire shaded area is exactly 1/3 of the entire circle. Now hold it. Would you please think about that for a second? If the whole area is 254.47 and I want just 1/3 of that, then I simply take my whole area times that fraction, Remember, the whole area is 254.47, and I want to find just 1/3 of it, so 254.47 times 1/3. And use your calculators. I'm rounding a little bit, so if you're off, a couple hundredths, that's fine. You should get 84.67 square units. That's the area of the blue shaded area. And that makes sense because the whole area is 254 and 1/3 of that is about 84.67, okay? Now, you would probably like some steps. Some of you would. So let me give you some steps, all right? If you like steps, here they are. Step 1, I'm going to write them quickly. Find the whole area, okay? Step 2, find the fraction, not the area, find the fraction of the sector. Okay, and then put a fraction and put 360 in the bottom and kind of put X up top, okay? Because what that means is you're going to find the fraction of the sector by using this here, whatever your degrees is over 360. And then step 3 is you simply multiply step 1 times step 2. So whatever you got out in step 1, the area, and whatever you got out in step 2, the fraction of the sector, simply multiply those together and you're finished. I'm going to pause. I know a lot of you like steps, so I'm going to leave those steps up there. Some of you understood this explanation. You don't need these steps. You're like, oh, that makes sense. Find the whole area, then find what fraction this sector is, and then whatever fraction it is, multiply it times the whole area, and I'll get out my fraction. That's fine. Others of you need steps, and that's fine also. So copy these steps down, please. And we'll do one more problem and we're finished. Find the whole area of the circle, find the fraction of the sector, multiply steps 1 and 2 together. Okay, if you got to pause the video, do so. I'm moving on. You can work ahead or watch me. Work ahead or watch me. Step 1, find the area. All right, so area equals pi r squared, right? So I've done the math for you already. The area is 28.26. Isn't that easy? Step 1, find the area of the whole circle. All right. Step 2 is find the fraction of the sector. Find the fraction of this sector. And I told you to put 360 in the bottom and put this angle right here up top. Now let's reduce that. Divide the top and the bottom by 10. So it looks like your fraction is 736. All right. So here's your area from step 1. Here's your fraction from step 2. And then step 3, you simply multiply those two numbers together. Now everybody in the class has different calculators, so you're going to have to figure out how to use your calculator. I'm sorry, that's just how it is. Maybe you can help each other. But if you take 28.26, that's the whole area, times the fraction of the shaded area, you will get out approximately, rounded, 5.5 square units. Okay, I'm going to be done with this video in a second. I'm going to go right into the help video for tomorrow. So tomorrow when you're doing your homework or late at night at your house or whatever, please let the help video help you. Okay, that's what it's there for when it comes to your homework. So that's it for today. Here's your homework. Again, I'm not going to write out Berean Academy Geometry. I'm just going to put BAG, B-A-G. You know that's Berean Academy Geometry. 8 dash, there are spaces between all the words. There's a space here, 8-7, and then a space, and then the word homework. Okay, so that's the video that will help you if you're stuck on your homework. And here's the problems I want you to do. All right, have a great day. Be ready for Friday. We'll start reviewing for the test on Friday, review on Monday, and a test on Tuesday. Lord willing, I should see you guys on Tuesday.